The last section of Chapter 4 is looking at solving rational equations and using equations to solve problems or application questions. This first lesson, we'll look at solving the equations, and as a warm-up, you've already solved 2 quadratic equations just as a review of what you've done in the past. The answer to question 1 is up already. Question 2 I wanted to take some time to go over with you, because when we have a coefficient that is not 1 in front of the x squared term, there's an extra level of challenge to these questions. So let's take a look at it. So what we'll do is we'll write down the 2x squared, and we'll write down the plus 12 equals 0. But then this middle term, we want to decompose into 2 separate terms. And to do this, we look at the 2x squared and the 12 and multiply them together to get 24x squared. And we want to know what 2 numbers will multiply to give us 24x squared and add to give us this middle value of negative 11. So as we think about factors of 24, 8 and 3 come to mind as 2 that will add to 11, multiply to 24. Since we want a negative 11, we can make it a negative 8x and a minus 3x. Once we've done this step, then we will group the first 2 terms together, and we'll group the last 2 terms together. But you'll notice, in my grouping here, I made a mistake. I need to make sure that the negative sign with that 3x stays with it. So I'm going to change this to adding a negative 3x. Then I'll take a common factor out of each of those 2 binomials. In the first one, there's a 2x that I can factor out, and I'm left with an x minus 4. In the second one, I can factor out a negative 3, and I'll be left with an x minus 4. Because again, remember, when I factor a negative out from that positive 12, I'm left with a negative 4. Then I can see that I have this common factor of x minus 4. And that common factor I want to factor out at this time. So I'll have an x minus 4 that I factor out. Once that's factored, I'm left with a 2x plus a negative 3, or a 2x minus 3. And that gives me my second factor. Setting each of these equal to 0 will give me my 2 values for x. So there we have it. X could equal 4, or x could equal 3/2. If you put your answer in decimal form, that would be fine. So again, we call this decomposition, and that key step is what's written in blue close to the top. You can read as well as I, so the definitions I'll leave up to you. You are expected to know this terminology. So let's move on to the examples. Beginning with example number 3, step 1 lets us know that we need to determine non-permissible values to begin with. So at the start, we can see that our x value will not be able to equal a positive 2. So we'll just store that information for now. Step 2 tells us to multiply both sides of the equation by the lowest common denominator. In the case of this question, there is only one denominator, and so this x minus 2 will multiply on the left, and on the right we'll multiply x minus 2 as well. What happens when we do this on the left is that the denominators can cancel out, and we'll have 3x equaling 4x minus 8. So I took that 4 and I distributed it into the parentheses. Then I can collect like terms to the same side of the equation, so I'll subtract 4x on both sides, which will give me negative x equals negative 8, which means positive x will have to equal positive 8. The operation that we did to get from the second last line to the last line, we could look at either as dividing both sides by -1 or multiplying both sides by -1. Since we end up with a value of 8 for x, it's not the non-permissible value, and so this is an acceptable solution. Looking again at the procedure, we did step 1, determined non-permissible values. Then we did step 2, we multiplied both sides of the equation by the common denominator. Step 3, we eliminated common factors, this x minus 2 and that x minus 2. We got this simplified equation here, and we solved it to get our final answer of x equals 8. On to question number 4. This time, as we look at the lowest common denominator, we have a denominator on both sides of the equation. So we'll multiply both sides by x plus 3 and 4x plus 7. So when I multiply the left side, these x plus 3's cancel out, and on the right side, the 4x plus 7's cancel out. Now we could think of this as cross-multiplying, and that would save a step, but when the equations get more complex, cross-multiplication doesn't work. So at this point, we can multiply the 3 times that 4x plus 7 on the left, and on the right we'll have 9 times x plus 3. Distributing to get rid of the parentheses, 12x plus 21 is equal to 9x plus 27. Subtracting 9x on both sides, will give me 3x on the left, and subtracting 21 on both sides will give me a 6 on the right. And we solve to get x is equal to 2. But I jumped into solving this equation without checking to see what my extraneous values were. So that would be a possibility to leave it to the end. Just there's the risk that we might forget. As we look at the denominators, we had x plus 3 can't equal 0. If it equals 0, that's non-permissible, so x equaling 3 is a non-permissible value. And from the 4x plus 7 equaling 0, we would get x equal to -7/4. So those are the non-permissible values that we have. And so our solution, x equal 2, is not one of those, so it's a good one. X equaling 2 is not extraneous. Let's move on to example 5. In example 5, now our denominators are a little bit more complex. So we'll start by looking on the left-hand side, and we'll factor this denominator. We can take out a common factor of x, so that denominator is the same as x times x minus 1. So that will be our lowest common denominator, because as we can see on the right side, we have an x minus 1 as well. So maybe before we get to that, let's look at the non-permissible values. X can't equal 0, and x can't equal 1. So we'll keep those in mind for when we finish our solution, and we'll look back to check. Multiplying both sides by the lowest common denominator. On the left, we'll multiply by x times x minus 1. On the right as well, x times x minus 1. Then we can see the common factors that will cancel out. Both of those cancel with both of these, so this denominator is completely gone. Here x minus 1 cancels, and we're left with an x. And so right away we get 4 is equal to 1x, and there's our solution. Checking it against our non-permissible values shows that this is an acceptable solution, so there are no extraneous roots in question number 5. So we move on to question number 6. This time, as we look at the non-permissible values, we'll see that our denominator can't be 0, and that happens when x equals 0. So there's our non-permissible value. Looking at the denominators, we can see that our lowest common denominator will be 10x. So we'll multiply both sides of the equation by that 10x. And what happens on the left is this 10x gets distributed to each of these two terms. So often what we'll do to save a step is to multiply each of these two terms separately by 10x. And then as we look at it, we can see here the 10x is completely cancel. Here 5 goes into 10x 2x times, and 2x goes into 10x 5 times. So we'll multiply the 1 times the 5 to give me a 5. The 2 times the 2x will give me a 4x, and on the right hand side we'll have a 1. Isolating the 4x by subtracting a 5 on both sides gives me negative 4x equals negative 4, so x is equal to 1. Again, comparing this with our non-permissible value, x equaling 1 is our solution. So we move on to question number 7. In question number 7, we have just one denominator, so that will be our lowest common denominator, and like before, we'll multiply that x minus 1 to each term. I guess before I go further, I could state that my non-permissible value, x can't equal a positive 1. Coming back to the question, these x minus 1s will cancel out, and this x I'll need to distribute into those parentheses, as well as this 4 into those parentheses, which will give us x squared minus x plus 2 on the left, and 4x minus 4 on the right. Now we have a quadratic equation, similar to the two warm-up questions, except that we have terms on both sides of the equation. So as you'll recall, for solving quadratic equations, we want to collect all the terms to one side. So I'll have a 4x squared minus a 5x when I subtract 4x on both sides, plus a 6 when I add 4 to both sides. Factoring this, I'm looking for two numbers that will multiply to give me this positive 6, and will add to give me a negative 5. So we have x minus 2 and x minus 3. Setting each of those factors to 0, we get x equals 2 or 3. So we have two solutions. Neither of them are extraneous. So we move on to question number 8. Now we're looking a fair bit more complex. Each term has a denominator. As we look at our first term that's on the left, we can factor that to see that our denominator is equivalent to x times x minus 3. And so x times x minus 3 will be our common factor. Before going further, though, we can state that x can't equal 0, and it can't equal positive 3. So two non-permissible values this time. As with the previous two questions, we will multiply each term by that common denominator. And then we look to see common factors that will cancel out, and that'll get rid of all of the denominators that we had. So our left side is 18, our right side 6x, and this negative 5, I'm going to distribute into the parentheses right away. So remember the negative sign goes in as well, so I'll have a negative 5x plus a 15. So be careful with that second sign. It's easy to lose track of this negative sign that's going with the 5. That negative times this negative gives me this positive. Collecting like terms, on the left side I'll have an x when I combine the 6x minus 5x, and I'll subtract 15 on both sides, which will give me a 3. So I've solved, and I've got a value for x, but this time, as I look back and compare this to my non-permissible values, x equaling 3 is not permissible. And it's not permissible because if x was equal to 3, this denominator, 3 minus 3, would be 0. I'd be dividing by 0. Similarly here, 3 squared is 9, 3 times 3 is 9, 9 minus 9 is 0. I'd have a denominator of 0 as well. So for this question, I'm going to say that's a non-permissible value or an extraneous root. And so this equation has no solution. So this equation illustrates for us the importance of us finding these non-permissible values and then comparing them with the solution we get when we solve the equation. Let's move on. As we move towards solving problems, let's just take a moment to look at translating from words, from not a complete problem, but an expression in words, translating from that into a mathematical rational expression. So we want an expression that looks at the time it takes a plane to fly this distance of 675 kilometers when there's no wind. So to do this, we're going to recall that there's a relationship between speed, time, and distance. Speed times time is equal to distance. And if I want an expression that will describe the time, then I need to divide both sides by the speed, so the time is distance divided by the speed. So my variable, what I don't know in this expression, will be the speed of the plane. So I need to begin by defining that, and let's say that x will represent the speed of the plane. And we'll say in still air. And so my expression for time will be that distance of 675 over the speed, which is x. So this will be my expression that describes the time it takes for this plane to fly 675 kilometers. Question number 10 will be similar. Again, we'll want to begin by defining what our variable will represent. So let's say x will represent the speed of the plane in still air. And my expression, which will be distance 675 over the speed. This time, since I'm going against the wind, I'll have the speed of the plane and I'll have to subtract off the speed of the wind that's slowing it down. So this will be the expression that describes the time that the plane will be traveling. So we're not coming up with equations at this point, we're just translating from the words into an expression, and it's a rational expression. So just getting some practice with this before we get to the next lesson. So you will see at the bottom of the page your assignment, page 258, questions 1 through 5. So work through those, please. Once you've completed that, then you can look at the next lesson video and work on that assignment. So you'll have the rest of today's class. What I would like you to do is complete this assignment, and then before you come to tomorrow's class, watch the video. It'll be posted online, so you'll see a link for it there. So watching the video will be part of your homework assignment so that you can come to class tomorrow and you can use the entire class time to work on the assignment questions together with other people around so you can help each other understand. Okay, so that's it for today. Have a good day.